Welcome. This video is about modules. Modules are not compilation units like the modules you would know from C or C++. Rather, they are more like namespaces in C++. However, they also have some visibility rules. We shall see this in the examples. In this example, you see a module at work. You define a module just by saying mod A, and you can put the stuff for the module directly into a pair of curly braces here. You can put functions, definitions, whatever items you want. And if you want them to be visible to the outside, you put the pop keyword in front of a function, for example. Modules can contain modules. And again, there's the pop modifier for this. We talk about visibility a bit later. If you want to access stuff in a module, you have to quote it with the module name, unless we use the use statement, which we also see later. So this here calls the function f in the module A, which is visible in here. This here calls the function h in the submodule B down here. So these functions just print what they do. Here, f in the module calls g, and so let's see what this does. Indeed, we see f, g, h. F is called first, it calls g after printing f, and then it calls h. There's no big mystery here. Of course, you don't want to put all your code for all your modules into one file. So therefore, the standard layout for putting stuff into different files is as follows. It starts with a main.rs, which just declares the module. The code for the module then goes into a.rs, and the code for the submodule B of A goes into the subdirectory A with the name b.rs. Let's look at the code. Main is unchanged, except that it declares the mod A. That is such that the compiler knows that the compilation unit for this grade, the compilation unit for main, uses the submodule. That is, whenever this is compiled, the submodule is compiled as well. Now let's look at the A module. It's unchanged, except that it doesn't contain the module B, but it contains pop as the submodule B as a public module. And finally, if I go to ab.rs, I have the code for the submodule B. If I build and run this, it behaves exactly as before. Summing up, the main code is in main. It declares submodules of main. Direct submodules are in a.rs files with the name of the module. And submodules go in the directory hierarchy that all intermediate modules are directories, and the bottommost is a Rust file. There are other possibilities which we will see later. We don't always have to use full path names for access into modules. Rather, we can use the use statement. For example, this here, after the module has been declared, well, the order doesn't matter, but here I'd say that I want to import the function f from the module A into this current place here, the main module, if you want. If I do this here, I can just call the function f unquoted, so just with its name. There's also a second syntax to import something deep down and give it here a different name. So this HHH here calls the h function in the submodule B of A. Let me see how this works. And indeed, it does. It's also possible to import multiple things within a single use statement. First of all, you can comma separate them, but you also can use a kind of distributive law if you use the curly brackets here. So for example, this imports exactly as before the function f from module A and the function h from the submodule B in module A. So these are just multiplied out. And in this case, I can just use f and h as here. Let me see how this works. Yeah. It works as before. Let's talk about the visibility rules. For this, I go back to the single file solution. So I again have my main module, and then I have the submodule A and the submodule B in A, all in one file. It's the same program as before, except that I have added a function call in here in the function h, and I go up in the hierarchy. Note that the compilation unit for all these modules is called crate, because that's the name for the current compilation unit, and I can refer from the top to the function g here. Notice that this here is possible, although the function g is not public. So a submodule B can see the private functions one or more up in the hierarchy, but it doesn't work the way down. So this here works. H can actually call G upstairs, but if I put a function I in here, first of all, it complains that it's not being used. If I now would try to call I like this, up here, it's not allowed because the function I is private, it's not public. So therefore, I cannot call from the module A into the submodule B. So private stuff can be used upwards, but it cannot be used downwards. If I put up here, it does work. Other than that, so the function main can use stuff in the module as long as it is public. So therefore we need this pub here. It can access the function h because it's public in B, and the module B, the submodule B in A, is public in A. Otherwise the function main couldn't reach in. So if I leave out this public here, I get a complaint that the submodule B is private. I cannot access it from the outside. So therefore I need this pub here. I don't need a pub up here because f can call a function in the same module. I need a pub down here because again I'm going down in the hierarchy. And I don't need a pub for G here because I'm just going up in the hierarchy from B outside. Let me conclude with two special things we still miss. First of all, recall that crate is the name to go all the way up in the current compilation unit crate and go down with a full path. I could have done here the same by saying super. Super is essentially like going up in the directory hierarchy. It is just the super module of the current one. So this here works exactly the same. And the other thing I wanted to show you is that I can use self to mean the same module. This is quite often necessary in templates, but it's just good to know that you have super and self and crate to refer to modules. This gives you essentially a complete path system to access stuff in modules. This is it for this video. I hope you enjoyed it. I've shown the module system, which is both simple and versatile, and therefore I like this setup very much. Goodbye.